Hello and welcome to Sudeepa tutorial. Today we will start the first chapter of grade 9 CBSE Science, Matter in Our Surroundings. In the first module of this topic, we will study about the physical nature of matter and the characteristics of the particles of matter. So let's start. Everything in the universe is made up of materials which scientists have named matter. The air we breathe, the food we eat, the stones, the cloud, the stars, the plants, and the animals, everything that you see around is either a solid, a liquid, or a gas, which we call as matter. And you have already studied that matter has the following properties: matter has mass, and matter occupies space. Since early times, human beings have been trying to understand their surroundings. Early Indian philosophers classified matter in the form of five basic elements, which they called as Panchatattva. The Panchatattva consists of air, earth, fire, sky, and water. Ancient Greek philosophers have arrived at a similar classification of matter. Modern day scientists have evolved two types of classification of matter based on their physical properties and chemical nature. In this topic, that is chapter 1, Matter in Our Surroundings, we are going to study about the physical nature of matter. While we study the physical nature of matter and the details of the particles that make up matter, we will come across many activities which I will describe you gradually. After you complete watching and listening to the video tutorial, kindly solve the questionnaire that is present in the description box below. So let's start. 1.1 Physical nature of matter. We all know matter, that is solid, liquids, and gases, is made up of particles. But when we say something, we do need to have a proof of it. For that, let's perform the activity 1.1. There have been debates about the nature of matter. The questions that arise are: is it continuous, like a block of wood, or is it particulate, that is made up of particles? This experiment will clearly show us the nature of matter. Take a beaker containing water, measure its initial volume. Add to that 2 tablespoons of salt or sugar, that is solute. Stir it well and measure the level of water again. Do you observe any difference in the level of water? Obviously not. There is no difference in the level of water though you have added 2 spoons of solute, that is salt or sugar. Why does this happen? The reason to this is the particles of salt or sugar have entered in the spaces between the particles of water. And this has happened only because matter, that is water, is made up of particles. Salt or sugar, that is, they are also solid matter. They are also made up of particles. This proves the particulate nature of matter. Now that we are clear that matter is made up of particles, what are these particles like? How small or how big are they? To understand this, we will perform the next activity 1.2. In this activity, as you can see in the diagram, we have taken 100 milliliter beakers, 5 to 6 in number. We have filled them up with equal quantity of water, that is maybe 100 milliliter in each of the containers. And we take 3 or 4 test tubes. We take a spoon in which we add just 2 or 3 crystals of potassium permanganate. For those who are not aware, potassium permanganate is a chemical which is dark pinkish in color, or maybe you can call that as magenta. It is similar to the color that you see in the beaker second onwards. What we do is we add this potassium permanganate crystals and stir it well. You will observe that the colorless water becomes dark pink in color. You transfer 10 milliliter of this water and pour it in the next beaker. After a while, you will observe that the water in the third beaker too turns pink in color. From the third beaker, you again transfer 10 milliliter of the colored water in the test tube and transfer it to the fourth beaker. In this way, as you keep on transferring the water, you will observe that the pinkishness of the color gradually turns paler and paler, meaning to say that when you had added the potassium permanganate crystals in the first beaker, it was dark pink, and as you can observe in the following beakers, it becomes lighter and lighter. This clearly shows that the particles are very small and beyond our imagination. That is the reason why the first beaker is dark pink in color, while the color or the impact of the color of potassium permanganate crystals gradually fade. So from the second activity, we can understand that particles of matter are very small and it is beyond our imagination. Now let's continue with the third activity. You have always observed and felt whenever we have lighted incense sticks in our house, the fragrance spreads to long distances. Even for that matter, whenever a food is being cooked, you can identify the food just by the aroma of the same. Same applies when we spray powder or perfume or even room freshener. The question is, why does this happen? This happens because the particles of one type of matter can easily mix and enter the space in between the particles of the other type of matter. This property of matter, being able to mix with another type of matter, is known as diffusion. Now let's come to activity 1.4. You take a beaker or a glass full of water and then pour a drop of red ink or blue ink in that. It is quite similar to activity 1.2 in which we had mixed a few crystals of potassium permanganate. In this, just the difference is you are mixing one liquid with another liquid. There, you had mixed one solid, another liquid. What do you observe when you drop the ink in the glass of water or the beaker? You observe after a while that the entire water turns the color red or blue as the ink's color is, right? Why does it happen? It happens because of the same reason. The particles of matter enter in between the spaces of the molecules of the different type of matter. The ink particles occupy the space among the particles of water. But there is a slight twist to this. In this activity 1.4, there are a few different types of substances which are being mixed. For example, if you take one drop of ink, it will mix fast. But if you take a slightly heavier substance, for example, honey, it will take a little bit more time to mix with the water. So definitely, how heavy or how light the substance is, that is, how dense or less dense the substance is, will also determine how fast or how slow the two substances mix with one another. Now, coming to activity 1.5, this is an observation that you make every day. You will always find your mother mixing sugar in warm or hot tea. And for that matter, whenever she adds milk food like Bonvita or Complan in the milk, it is always a bit of lukewarm, warm, or even hot milk. She never does the same in cold milk. Why do you think she uses this logic? To prove this, we will do this experiment in which we take a beaker containing water and you can see in the picture blue crystals of copper sulfate. So when you add copper sulfate crystals in water, you will find the water contained in the beaker turning blue. But an experiment has been performed to observe if boiling water has some effect on the solubility of copper sulfate. To perform this experiment, boiling water was taken and copper sulfate crystals were added into it. It has been found that the solubility of copper sulfate increases This proves that temperature definitely has an impact on the solubility of substances. But the question is, why so? I'll take you back to another property of particles. Particles, which are also called as molecules, are in a state of constant motion. And when you trace the motion, you will see it is completely haphazard. There is no distinct way by which it moves. It can move randomly. When substances move, it is true that they have kinetic energy in them. When you are heating a substance, the kinetic energy of the molecules increases. When the kinetic energy of the molecules increases, it allows more space among themselves for the entry of the molecule of another matter. So, when you added copper sulfate crystals in the boiling water, water which was in the state of higher kinetic energy, because it was getting boiled, it allowed more space for the crystals of copper sulfate to enter within it freely. And so the solubility increased. So we have concluded from this experiment that temperature has a positive influence on the solubility of substances. Now coming to activity 1.6. We know that matter exists in three states: solid, liquid, and gases. And we can certainly state the characteristics of solids, liquids, and the gases because they are very distinct from one another. But the question here is, why so? What makes a solid the way it is? What allows a liquid to flow? And why does it happen that a solid has a fixed volume while gases don't have? To answer these questions and even more, let us take the examples of three different dance forms to understand it very easily. The dance form 1, you see, the girls or the dancers, they are holding one another from behind, keeping their hands in a crisscross manner. For the next dance troupe, you see, they have held their hands in front, but they have held it tightly. In the third dance forms, the dancers have connected to one another just by the help of their fingertips. Now, if a very simple question is asked, how firmly are the girls of the three different dance troupes holding each other? The answer is very simple. The first one is the most tightly held. The second one is also tightly holding themselves, but little less tightly than the first one. The third one, the dancers can be very easily separated. This is just an analogy to how firmly are the particles of solid, liquids, and gases bonded. So you can compare the bonding of the solid particles with the first dance troupe, while the liquids with the second, and the gases with the third. And because the bondings are so tight or so loose, is what allows them to perform differently. That is, they have different characteristics, whether physical or even chemical. Now, coming to the next experiment, 1.7. Here we take three solids. Mind it, we are taking three examples of matter. One is a nail, which is made up of iron. Another is a chalk, which is made up of calcium carbonate. And the third is an elastic rubber band. Whether it's a nail, a chalk, or an elastic rubber band, all of them are solids. In this activity 1.7, we will try to show that even solids can behave differently. Look at the nail. We are trying to hammer it. When we hammer a nail, two things can happen to it. Either it will go inside the block of woods, or it may not go inside, it may even bend. In the next experiment, a very simple wedge, whether it's a blade or it's a cutter, it can easily break the chalk into powder. When you apply force on a rubber band, what happens is it stretches, and you can stretch it to a large extent till a point comes when it breaks. So observe that a nail a chalk, and a rubber band. All the three are solids, but they have behaved differently on the application of force. This is something that you need to note, that even solids can behave differently from one another. Now coming to the last activity, that is activity 1.8. Let's check the application of force on this particle. Have you ever tried to cut a continuous flow of water? That is, maybe the tap is on and you try to run a wedge, that is a pair of scissors or a knife, through the water. Could you ever break the continuity of water? No. Whether the force is light or the force is of high intensity, you cannot break the continuity of the particles of water. So, from the above four experiments or activities, we have come to know that the particles of matter have force between them. This force keeps the particles together. The strength of the force, that is, the force of attraction, differ from one kind of matter to another. And with this, we end with the first module, and this is what we summarize. Matter is made up of particles. The particles attract each other with a kind of force. The intensity of force between the particles is maximum in solids, lesser in liquids, least in gases. The particles are in a state of continuous motion and possess kinetic energy. This kinetic energy increases with temperature. Molecules diffuse with one another. Like, share, and subscribe to Shudeepa Tutorials. I will keep on updating more and more such videos. Kindly solve the questionnaire present in the description box below. Thanks for watching.